Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistants. And today we will be determining empirical formulas by their percent composition of the species within them. The problem given says determine the empirical formula for the compound that is composed of 88.81% oxygen and 11.19% hydrogen. So the first thing to recognize is that we cannot use just percentages to determine this, but we can use masses. We need to get to masses. If you were to think of this molecule, this mystery molecule, as having a mass of 100 grams, then you could readily determine that 88.81 grams are oxygen and 11.19 grams are hydrogen. So the first thing you're going to want to do is to convert your percentages to masses out of 100 grams. So your mass of your oxygen, we'll call it M sub O, is equal to 88.81 grams. And your mass of the hydrogen, M sub H, is equal to 11.19 grams. So then we want to recognize that in order to determine the empirical formula, we need to convert these masses to their respective moles. So to find the moles of hydrogen, we're going to take 11.19 grams and multiply it by 1 mole over the molar mass of hydrogen, which is 1.008 grams. And you'll note that grams and grams cancel each other out, and you're left with moles, which is what we want. So this molecule could potentially be 11.10 moles. The next thing we'll want to do is to find the moles of oxygen. So we'll start by using the given, 88.81 grams, and multiply it by its molar mass, except having the moles at the top again, so really it's dividing by the molar mass of oxygen. We know that to be 16.00 grams per every 1 mole. And again, grams and grams cancel each other out, and we're left with moles. And in this case, we end up with 5.551 moles. The next thing you want to do, and making sure that we've covered every species mentioned, and we have, only oxygen and hydrogen exist in this molecule according to the start of our problem. So we know that it's going to be some composition of those two species. And in order to find out the number of moles that are set as the subscript for each respective species, we want to create a relation between them. So you're always going to assume that the least number of moles, in this case denoted as oxygen, because 5.551 is less than 11.10. So oxygen is going to be by itself. There's not going to be a subscript on oxygen. Please keep in mind that this is the empirical formula. You would not be able to do this with a regular molecular formula unless you are given further guidance on other aspects of it. So the relation between 11.10 and 5.551 is relatively easy to calculate. All you have to do is take 11.10 moles and divide it by the 5.551 moles. And then take it to the nearest integer. And in this case, we end up with 2. Because 11.10 is roughly 2 times 5.551. Therefore, we know that our oxygen is going to have a subscript of 1 because it is the least moles, the least amount of moles. And our hydrogen is going to have a subscript of 2 for this empirical formula. Therefore, our formula is simply H2O. And that's it. That's all you have to do to determine the empirical formula through percentages.